Okie dokie, artichoke. So, the next question that we have on the menu today. How do you find the derivative of d over dx of... I'll just take the right side because I guess we don't really need the y. Of tan x, thanks for that, plus cotangent of x. Okay, so let's before we handle this, let's do some equivalences, some trigonomic identities that can possibly make this easier to handle. Because if you look at these graphs for tan and cot, they're a little bit spicy in terms of what their graphs look like. I think it's going to be a little bit more easy if we know that like tan of x is equal to sine of x over cos of x, and cotangent of x is equal to cosine of x over, you guessed it, sine of x. Well, hope you guessed it. And if we substitute those into there, we're just going to have two product rules to deal with. I mean, not product rules, quotient rules to deal with. So let's write out the quotient rule. D over dx of some function divided by some other function is equal to the derivative of the top multiplied the natural bottom. Okay, let's get a little bit more space. Minus the natural top minus the derivative, or times the derivative of the bottom, all over the bottom squared. The natural bottom squared. Okay. So let's rewrite this equation first. That's equal to d over dx of sine x over cos x plus cos x over sine x. Okay, and we're gonna need to do the product rule, I mean the quotient rule, for both of them. Both need quotient rule. Good thing I'm teaching math instead of spelling. Okay, cool. So let's get it started in high. Okay, let's do the first one first. I'll actually recolor that to be a different color just so that we can see like the differentiation. Let's make you red. I can't make that red, but that's okay. Okay, so let's do the first one first, or yeah, the sine over cos. So the natural of the front, or the derivative of the first, so that's cos squared x times the natural of the bottom, so that's cos squared s, or cos x, minus the natural top times the derivative of the bottom, sine x, and the derivative of the bottom is negative sine x, all over the bottom squared. Okay, now in black we can do its neighbor over here. So the first thing is going to be the derivative of the top times the natural bottom. So that's negative sine x times sine x, that's the bottom, minus the natural top, so cos x, multiplied by the natural bottom, I mean the derivative of the bottom, so that's just cos x. We'll just rewrite that to be a little bit more clean and crisp and clear. And okay, and what's on the downstairs of this whole thing? Sine x squared. Okay, let's expand this out. So on the top, we got cos squared of x minus, so those minuses, the negative sine x and the minus out here, they neutralize each other, so we get plus sine squared x. And then cos squared x on the downstairs, plus all the way over here on the first term, we got sine x times negative sine x, negative sine squared x, negative cos squared x, all over sine x squared, sine squared x, same thing. Okay, now what? Hey, you remember that trigonometric identity that you got cos squared x plus sine squared x? You add them together and you get 1. I remember that. Note 1 equals sine squared x plus cos squared x. And there's a negative version of that. Negative 1 equals negative sine squared x minus cos squared of x is equal to negative 1. Well, that's really just the top equation multiplied by negative 1, but you see, hey, maybe on the top of the left one, we got, you can convert that to a positive 1, convert that to a negative 1 up here. So we just get 1 over cos squared x plus a minus 1 over sine squared x. We can rewrite this as secant squared of x minus cosecant squared of x. And that means the same thing, but it should be perfectly valid for you to leave your answer as either what you see here or what you see here. Should both be valid. Okay, awesome. Now, did they come to the same conclusion here? Let's see it. They absolutely did. So, we are doing good. Oh, they just had a little bit of a different process. Like, they're directly taking the derivatives, because I know the derivative of tan and derivative of cot, but if you go with the quotient rule, you can see where that comes from and how that's derived in the first place. That was good. So, the above solution is correct. Interesting. I think that was the last question on the menu today. Time flies when you're having fun, as the old saying goes. Just gotta bring over some stuff. Okay, so those are all the questions for today. If you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and hit the notification bell below. If you would like to submit your own questions, please visit the links in the video description below. Remember to leave a like and a comment, and share this video with your friends if you liked it. This has been Millen with OneClass. I hope to see you soon. Goodbye. Have a good night. And I hope all of your mathematic dreams come true.